BFGS, it only supports L2 penalties, so I have to write here L2 and run. And now we have completed, we have got the cross validation best accuracy 97%. We can calculate the F1 score, which is 96, which is very good. F1 score is between 0 and 1. Remember that accuracy is 95 on the test set. The confusion matrix has good true positives and true negatives, and the classification report is giving us the precision recall. We just have to write it like this: print classification report. Okay, so we see the precision recall F1 score for both this class and this class. We see the accuracy overall as well as the macro average and the weighted average for the accuracy. So overall, this has been a very good logistic regression model on the data. You can now replace the parameter grid with you can replace this grid with the bigger grid, and it will take a lot of time, maybe half an hour, but you will get a better model with a better accuracy. Last was the ROC curve. So let us see how we can calculate the ROC curve. We need Y test and Y pred. Let us see if that calculates the ROC curve. Yes, so ROC curve is also explained here. It gives us the false positive rate, which is this true positive rate, and the threshold. Then there is the ROC curve AUC score. So this is an important metric. ROC, this tells us about the performance of the model. It should be close to 1. So it is high, which means it is a good model. Can we plot the ROC curve also? I think we can. There is a function ROC estimator, ROC curve display. So to use that, we have to do like this. Okay, so this will plot the ROC curve. We have ROC curve here. We have the Y test and Y predictions, and then the metrics. Okay, Scikit-learn AUC. So this we have to import. Import Scikit-learn, and then we can write here Scikit-learn.metrics and Scikit-learn.metrics. We have some estimator name, which is Logistic Regression. Okay, so as ROC curve, as it should be touching, the curve is touching at this point, that means it is a very good performance measure for the logistic regression. It is far but not so far, so it is a good ROC curve, and our model is in general very good. So let us summarize what we have done, and then we can go to the next video. First, we have imported the libraries. Next, we load the data set. We do not need any pre-processing because there are no missing values, there are no duplicate values, there are no non-numeric values. So we split the data set into train and test, where the test is kept at 20%, then standard scaler, then grid search, and then finally the best model is evaluated on the test set, and we calculate F1 score, AUC, accuracy, confusion matrix. Okay, so now that we have written the code, we had seen previously the steps. We can just copy each step. So here we have load the data set. Next is the data preparation, which was done here, but there was no need for data preparation, so that steps we have not done. Then we saw split and test and standard scalar that we can do in this stage, as well as stratified sampling. Then we have grid search, finding the best model, evaluating. These 3 steps we have done over here. And the last step, which was to evaluate the performance, we have done right from these things. All of this is present here. So what is the meaning of this? Now that you have completed logistic regression and you have got a model which is like this. The model is a logistic model, so it will have a coefficient. Each feature will have some weight, and that weight is given in the coefficients. And each model has an intercept, so that intercept is given by the intercept. So remember that logistic regression is having the mathematical formula something like this, that y prediction is equal to the coefficient multiplied by the x features, so x plus the intercept. And actually it is not just the multiplication, but this is then passed through the sigmoid function. So all of this operation gives us the prediction, and now we have calculated the coefficient and intercept. The coefficients are so on. But what is the meaning of these coefficients? So for that, the meaning is slightly difficult to understand. So there is a good link, that is interpretation of logistic regression coefficients. There are many resources. One which I find very useful was by the author Quantify Health. Okay, so this is that link. How do we interpret the logistic regression coefficients? Suppose the coefficient is negative 1.93 and the coefficient is 0.38. So what is the meaning of this 0.38? So since our factors are all numeric factors, so we go to the section where we have the numeric variables. Okay, suppose we have got 0.38 as a coefficient for a numeric variable, so we have to do e raised to 0.38, which is 1.46. So what is this 1.46? An increase in 1 unit of that factor multiplies the chances of heart disease by 1.46. So for us, we have a factor here which is, let us see the names of the factors. X dot columns. One of the factors is mean radius. So when mean radius is increased by 1 unit, then chances of breast cancer increase by e raised to, what is the coefficient of this? Negative 0.20. So e raised to this. E is, remember,